Good morning, friends. Today we are going to see the daily question of Leetcode, which is numbered as 386 lexicographical numbers. First, we'll go through the question. Given an integer n, written all the numbers in the range including 1 till n sorted in lexicographical order. You must write an algorithm that runs in order of n time and uses order of 1 extra space. So yes, we'll go through example 1. Example 1 gives us that the number starts with 1 and then it checks for 1 and 0 which is less than n, so they are adding into the list. It checks for 1 and 1 which is less than n, they are adding into the list. 1 2, similarly 1 3, and they'll check for 1 4 which is not less than n, so they will be not adding into the list. So I can say that I'll be given if you are given with me a starting value of 1 2 3 4 5 6 7 8 9, then I can start appending the second digit to it, and I can check that number with the current with the max number n, and accordingly I can append that to my my answer list. So yeah, here we can clearly see that the answer list consists of the size n. So I'll be creating an array vector of size vector which is answer. Now this answer will be resized to n. Okay, now when I this we can clearly see the recursion pattern, and we can use recursion for solving this question. So as I don't want to pass answer into the recursive function, so I'm creating it outside. And if I'm not passing answer to the recursive function, and I also don't want to pass the index of the where I need to append that into the answer, so I am creating index outside. I'll let you know like why am I doing it. So I'll be calling the DFS function for the every digit, and the starting digit should not contain 0. So okay, basically I mean that starting we are not having 0, but the second digits are having 0 1. Second digit starts from 0 1 2 3. So for simplicity purpose, what I'll do is I'll start with 1 and it can go till 9, and this calls the val function and val n. Now this is a void function DFS into val 10% n. Now I can say that if my value which I'm passing at each intermediate step is less than or equal to n, then I am supposed to store that answer, store that particular value into the answer. So I'll do it index, and in the same like this will ensure that the index will be updated post this line. Once after completion of this line, the index will be incremented, and if my value is greater than n, then I'm supposed to stop there itself. If my now I have the value which is less than n, less than or equal to n. So what I'll do is I'll have for the second digit I will have values till for I equals 0, I less than equals to 9, I plus plus. Then here I'll be calling the function of I need to uh, suppose think it of in this way. Suppose the number is 56. Now my current value is 2. So when I am entering into the loop, I need to check, I need to increment this value, right? I need to I need to make this 2 into the currently 2 is in the unit digits. Now I need to make it into the tens digits. So for getting it into tens digits, I'll multiply that with particular number 10, and I'll add this value of 0. Then for the next thing also I'll multiply that with number 10, and I'll add 1. Similarly here I'll multiply the number of val with 10, then I'll add digit 1 at the as an unit place, and I'll be calling n. So yeah, let us run this. I didn't initialize it the integer I, so that's the reason it is throwing me an error. It's accepted. Let us try running it with the larger constraint n, which is 5 to 10 to the power 4. Yeah, we are able to get the answer. We are getting the correct answer. So here what's the time complexity? The time complexity will be the time complexity will be simple. Here for at max we are iterating over the at max the val can go till n. It starts from 1 and it can go till n, and as we are returning the like if we are going beyond the n, we are returning that, so value can go till n. So our algorithm takes order of n time. To be precise, for each index, I mean if I am at suppose what I mean to say is, here we have 5 into 10 to the power 4. Suppose I am at 1, in the starting value is 1, so I'll be adding a value of 0 0 0 0. I mean I'll be adding four digits to value of 1, and similarly I'll be adding, then replacing this 1 with 1, then replacing the 1 with 2. This is an this addition will be, this extra addition will be order of the time complexity boils down to order of 1, because the number for that particular number we are adding extra values of we are appending the values of 4 values to achieve a number which is less than 510 to the power 4. And we are not using any extra space. What I mean we are not using any extra spaces. We are calling a DFS function which is of a stack, which is a recursive function which operates like a stack. So given me a number, if at any point of the state given me a number, again if my current state is 10, I can on top of that my first initial start state will be 1. On top of that state I can go till 10. On top of that state I can go till 100. On top of that state I can go till 1000. I mean for I am saying that suppose given n is equals to 50,000, 50,000, 500 to the power 4. So in the starting state it is 1. Then on DFS this function will be called again, and I'll go till 10, and again this DFS function will be called again. I can go to 100. my value will be 100, and DFS function again this will be called and my value will be 1000. Again my DFS function will be called and my value will be 10,000. Post this, again my DFS function will be called and my value will be 110 to the power 5. And whenever I was into this situation, then I'll check my value is greater than n, so I'll return it. So post this, my value doesn't increase. So at max, I have a stack height. I have a tree height stack height of 5. At max, I have a tree height of 5. So and I'm not storing that. Apart from the answer, I'm not storing the individual state values at any point of time. So my space complexity will be order of 1. So time complexity will be order of n. Space complexity will be order of 1. Yeah, thank you.